it should work okay.
Yeah, it'll be fine. Yeah.
All right, you guys can see my screen?
Sure can.
Yes.
All right. So this isn't so much as a tutorial as it is me just kind of sharing what I've learned over the last few months and the things that I've learned. You know, specifically, I did try to document as much as I could over this past few days when I went out imaging in my backyard. So I was able to capture the Whirlpool Nebula, and that's kind of what I'm going to present here today. So, like I said in our introductions, I'm very new to the hobby. Barely started, what is it, 5-6 months ago, and I'm even more new to imaging. So, for the longest, every time that I went out to try to take pictures of anything, I ended up, you know, failing in some way or another. Either failing to focus the telescope, or failing to turn on the tracking, or, you know, trying to make my 130 millimeter telescope have a 500 times magnification. So everything that, every mistake that I made along the way, you know, I tried to take notes of it and learn from it. So now, when I attempt to go out and image, I attempt to plan the evening, make a checklist of what I need to be done. I can't tell you how many times I've gone out and you know, forgotten my battery, or forgotten the control on the focus, or one thing or another, some dumb stuff. So things that you know, you wouldn't normally think of could end up ruining your night. So I want to go over that, the setup, how I capture my images, and then how I process my images, and how I edit my images. So planning the evening. This is the actual view from my backyard. This is my house here. This tree is mine. It's a very tall maple tree, and I have my neighbors on the opposite side of the cul-de-sac over here, and then I got other houses over here along with the neighbors and their trees. So my view of the night sky is pretty limited. So whenever I do have the opportunity to go outside, I want to make sure that I take the most advantage that I can out of the evening. So I like to try to determine what objects will be visible during the night, when they will be visible, and for how long they will be visible. And you know, like I had the opportunity over this weekend, sometimes, if possible, to image more than one object in one night. So in order to do that, I use an app. I use Stellarium on my iPhone, and you kind of tell it what you're interested in and see where it's at, or where it will be at certain times. I've learned that, just from experience, that anything above this line, and I'm not really familiar with all the technical terms of the hobby, but anything above 40 degrees is pretty much visible from my backyard, from somewhere in my backyard. So in this case, M51, is it?
Yeah.
The Whirlpool Galaxy. I was able to determine that it would be somewhere around here, you know, around 10-11 p.m., and that it would do this kind of dance throughout the night. So I was able to use that to determine where to place my scope and plan ahead. Other things that have ruined my evenings before are the weather, because originally I'm from California. I've just been up here in Illinois for the last 6 years. And over there, you know, if the sky was clear, you could pretty much count on it being like that throughout the night. And, you know, over here, I've learned that things can change from 1 minute to the next. So even though it might look beautiful outside, you can set up your telescope, and then 15 minutes later, you know, clouds roll in for days, right? So check the weather, whether that's on your phone or through a website, and just kind of determine whether it's going to be worth it to put all that effort into going outside and setting up. And also, what's the moon doing and where's it going to be at? Obviously, you can just look outside, put your head out the window and see if it's out there. But if you're planning on leaving your telescope outside to take multiple images, or even if you're going to pack it all up and go out to the park or somewhere else with a better field of view, which I've done on a couple occasions, only because I got a very heavy mount and I really don't have any places close by to go to. But you wouldn't want to go and only to find out that the moon's coming out minutes after sunset, anywhere close to the object that you're attempting to image. So like I said, I do practically all my imaging from my backyard. And one of the things that is really unfortunate about my location is that I don't have a clear view of Polaris. So I have to make do with what I have. But even other small annoyances, I have to make sure that I remember to deal with them before it gets dark, before I plan on starting the session, because it's really hard to try to be fixing something or setting something up when it's dark, especially if you're dealing with small screws or small USB ports. So I make sure that my camera is charged. That mainly applies to when I first began this. I was using my Canon DSLR. Whether my camera was charged and the batteries were charged, but also, if you have a small internal storage, make sure that it's cleared and your SD card is memory is clear. I try to do most of my setup during the day, so like I said, so that when nightfall comes, I don't have to deal with as many of the issues that come up, and it's a lot easier to deal with them and solve them during the day. So I don't have a clear view of Polaris. So I use just my iPhone compass app and just try to aim the mount as close to true north as possible. Just get a ballpark alignment. I do my balancing, put on my scope on the mount and do my balancing during the day. If I'm going to be using a dew heater or dew control, I put that on the telescope again during the day. And if possible, I do try to use like objects across the field to do my rough settings on the camera during the day again, so that if there's anything that needs to be adjusted, I can do it. I can do it while I can see everything. Some of the adjustments that I make during the day are just like rough focus and just making sure that my guider is achieving focus at the same focal length as my camera. I may have missed the slide there, or maybe it's farther down the presentation. But another thing that I had to deal with and kind of learn for myself is on whether to use light pollution filters or not. If you go into the forums and you read what people have written before and the questions that people have asked before, or even if you ask the question yourself, you'll learn that everybody has different opinions, and even experts that have been doing this for a long time can have completely opposing opinions. So I have over the last couple 6 months obtained a couple of filters. My first filter that I purchased was the Bader Moon and Sky Glow filter, which is, I guess, marketed for being able to filter out most of the light pollution from city street lights and headlights. And I also have a just a simple UV IR cut filter. So I'm not certain exactly when I took these 3 images, but I think it was about 2 weeks ago. I just wanted to see for myself if they actually made a difference, and if so, which one was better. So these exposures that I took them all the same night using the same telescope and the same settings and same processing for all 3 images. All 3 images, I believe, are 30 1-minute exposures each, and then stacked. And, you know, after seeing this, I really can't tell the difference. You know, I mean, my filters are not very expensive filters. I think this one's around 130 bucks. This one's $60. And this was just no filter. And even if you zoom in, no filter looks pretty good. Honestly, the only difference is that if you really pay close attention, some of these stores are a little bloated because they do capture unfiltered ultraviolet light, so it makes them blow up. Whereas the other filters cut off the spectrum at the infrared and the ultraviolet, so you don't get any of that on your cameras, on your pictures. But I mean, I wouldn't spend at this point in time, after having experimenting for myself, at least personally, on any filters that are light pollution filters, anything that's more expensive than, you know, 100 or 120 bucks. Because I know there are some really expensive filters out there, and many a time I've been really tempted to try to get one. But from what I understand, our city lights and even our house lights and business lights nowadays are not like they used to be. They're mostly LED lights, which emit light in the full spectrum. And getting a filter that only filters out, you know, high pressure sodium or any of those specific wavelengths, it's not going to do much good against LED lighting. So,
Walter?
Yes.
Yeah, I have found that the dual, and I think Jim Reynolds has the same experience, that the dual narrowband filters or moderately narrowband filters, which are none of the ones you're showing here, do make a big difference in the suburbs. If for no other reason, and you're right about the broadband output of the LEDs, but if you've got the narrowband filters, you're not getting all the other stuff from the LEDs. You're only getting the stuff that's competing in the narrow bands that you're using with your filters. Now, those are in the range of 250 bucks, but you know, it's not that much more. I know what you're talking about. There are some quad band filters that cost like $1,000. I mean, it's unbelievable. Right. But the 2-band ones do work pretty well at suppressing the worst of the sky glow, but they're better for things like actually M42. They're not good for stars because the stars don't put out as much, the bulk of their radiation in those narrow bands.
Okay. You know what? I certainly want to learn more about it. I'll see if I can shoot Jim a note later and see which one he's using, and I can read up more about it. Maybe try it out one of these days. But these are the ones that I have, and honestly, I just stuck to the one I got first, and I just left it in the imaging train, and I hardly ever take it out.
Hey, Walter, I think another good test for you would be to pick a dimmer object and see what kind of results you might get, because the Orion Nebula is going to be one that is probably not the best of tests.
Good point.
I suspect that the Beta Moon and Sky Glow will do a little better job. Because I can see in the top right corner of it, there's some, faint grayish nebulosity up there that's not in the other two.
Is it this one?
Yeah, right where you're at. There's a little bit showing up there. So I'd be really curious to see what you would get in something that's dimmer.
Yeah, you know what? I haven't compared them on something dimmer like one of the galaxies. But all the pictures that I've taken recently, I've taken them with this filter, so I know at least that it doesn't block them, and it looks okay.
Right.
But I would like. That's a good point. I would be really interested to know if having just the IR cut filter would allow more lighting and allow me to get more detail without sacrificing any of the quality.
Well, I think Andy's right. It's a function partly of the brightness of the object. Of course, if you were to go out, where if you were remotely imaging like Herman, none of this would matter, right? But
it's true.
But by the way, the scales on these, I can't quite read them. How many nanometers is which? It looks
right. So I believe this is 700, and that's 400.
So that means that. Hold on. So that means the Optilong and the Beta, the only real difference is there are some notches near sodium and between oxygen 3 and mercury.
Right.
So all the stuff from 700 out is zilched in those two filters. So I would expect there wouldn't be a lot of difference, quite frankly.
Right.
And the IR and UV cutoff is similar also for those two.
Right. Mostly what people have complained about this filter on the forums is that it throws off the color balance, so it's hard to balance the colors in processing because it tends to produce a green tint due to the fact that it cuts off a lot of the orange yellow. But as far as the luminosity, as far as the brightness, at least on M42, it didn't make much of a difference.
Well, again, these three filters, I can't read what the scale is on the no filter. I guess it just cuts off wherever the cover glass of your sensor is.
Correct. And the scale on it is not to scale.
Yeah, I know.
I just got this one and this one from Beta advertising.
Yeah.
And this one I got it from a Google search, but the idea was to represent that, this one lets in most of the spectrum between these bands.
Yeah.
And this one cuts off some of the spectrum within those. The spectrum that oftentimes corresponded to light pollution, traditional old-fashioned light pollution.
Right. Discrete spectral lines.
Yep.
Like from sodium and helium, hydrogen, mercury, sorry.
Yep. Non-LED stuff.
Yep.
I was talking about polar alignment earlier. This is where Polaris is at my house.
Yeah.
It's not really this low in the horizon, but I didn't take a picture, high enough. But still, where it's at is being covered by this tree. And I can't move my imaging session to the east because then my house will block it. And I can't move west because then the big maple tree will block it. So what I've done is that I have my tripod on these hard furniture rollers, furniture movers.
Mm-hmm.
And I do the rough alignment. And then once I have my scope on it and I go to an object, I go to it and then I move the mount as carefully as I can and as much as is needed until the object is in the field of view of the telescope. And then I take the telescope back home and then do it again and see if it'll go to that object without going past it or missing it. And if I repeat that process, 2 or 3 times, I can get pretty accurate polar alignment without having a direct view of Polaris.
Forgive me, but I missed what mount is this?
This is the EQ6R Pro.
Skywatcher.
It doesn't have the all-star polar alignment that Celestron has?
No.
I'm not sure.
Skywatcher.
I don't think so. In order to align this mount, it has to. I have to have a view of the North Star.
Walter, you can look into something called Drift Align, which you can use to get really good polar alignment without seeing the North Star.
Yeah, the problem with drift align is you need to be able to see to do the elevation drift align, you need to be able to see the horizon.
Yeah, well, that could be a problem.
Yeah, I have the same. I have the same problem Walter has. I'm very familiar with the agony he's going through.
So
I'm very familiar with it.
at the end of the day, the whole polar alignment is kind of a moot point because what I use to control my imaging is the ASIR Pro, and it does plate solving. So it can follow a star regardless of how the mount is aligned. But I would like to one day get a perfect or a good polar alignment so that I can take longer exposures and all that good stuff. But so that's how I attempt to polar align. And as far as focusing, because again, when I first started doing this, I tried to eyeball focus, and obviously my eyes are not a camera. They whatever I see is not how a precise scientific instrument sees the world. So I would attempt to eyeball focus my objects, and then take 30 or 60-second exposures, and they would just be all blown up. It would just be nonsense. So I have focused either using a Batinoff mask or the autofocus on the ASIR Pro. I honestly, once that with the final images, either one is very precise. I really can't tell the difference as far as focus-wise, which one's better. One of them is just more convenient because you can autofocus. If you use the ASIR Pro, you can just autofocus on your phone from your couch. But also, you can use the ZWO autofocuser with other programs like SharpCap, and I'm not familiar with all of them, but it uses open source drivers, so you can use that with many different kinds of astrophotography software. And as far as image capture, like I said, after I go through all that and I planned out what object it is that I'm gonna picture that night, I set the auto run program and do my focus and then just run it. And I keep an eye on the output. It refreshes the image every time a new capture is complete, and be on the lookout for airplanes and meteoroids and branches from all the trees around my house, because they do sneak up on the picture and ruin it.
Yeah.
So, I'm not going to go through all the settings of the ASIR Pro because people use different things. You don't even have to use this. You can just take a bunch of pictures with your camera on a tripod and accomplish the same results. But in this case, on the Whirlpool Galaxy that I did last week, I set auto run to take 90 60-second exposures, no, you know what? For the image that we're going to be looking at later on the presentation, it was 120-second exposures, and I did that over a couple nights and then stacked them all together. I do use calibration frames because otherwise my pictures look like very dim on on the edges and very bright in the middle, and then all kinds of stuff in between. I take my flat frames using a very cheap tracing table that I got from Amazon. I think this thing cost me $12, you know, and I just put the white t-shirt over my telescope and turn the light table on, and then just, they go very fast. So typically I take 30 to 60 frames, which, you know, the camera does them in a minute or two. As far as my darks, I just put the cap on the telescope, and I point it somewhere dark, like, you know, the corner of my house or a tree or something, and then just take the darks. Those I typically do at the very end because they have to match the exposure time as your light. So, you know, in the case when I had 120-second exposures and I wanted to do 30 dark frames, you know, that's a whole hour of doing dark frames. You know, the reason I do all this is so that my images can look all flat across the field. One of the things that I did take away from the meeting we had in January was, you know, when Mark was talking about his camera and taking flats, and that he prefers sometimes to clean his sensor. So I attempted to clean my camera sensor. This is a flat frame that I took a couple months ago with my camera. And as you can see, it did have dust specks, dust particles on the sensor itself, along with one and maybe a couple other dust particles on the glass in front of the camera. Mm-hmm. So I thought, you know, I'm gonna go ahead and open this thing and just clean it up, and it's gonna be like brand new, right? So I ended up opening it up and then making it much, much worse. You know, I opened it up and then introduced, you know, dozens of dust particles. And then I opened it up again and got even more dust in there. So I closed it up and then just went on reading some more about how to undo everything I did. And what I ended up doing was I ordered a gel camera sensor cleaning stick. Mm-hmm. And that worked better than anything else I've tried, better than the liquid solution, better than, you know, lens cleaner. And what I did is I built myself a clean room in my bathroom. So I turned the shower on, hot water, let it get all full of steam, and closed the door for, you know, 45 minutes. And when all that steam condensed and fell down, it took all the dust particles with it to the floor. So I had myself a clean room for a brief period of time. And that's when I went ahead and opened my camera, plucked all the dust out, and closed it right back up. And this is what my sensor looks like now. I didn't get everything out. In fact, I mean, I cleaned all that out, but then I introduced new dust that wasn't there before, but it's not as bad as it was before. You know, I did introduce this dust speck on the lens, and this one directly on the sensor, and then this big planet-sized one right there. But I'm never going to open it again unless I have to.
Well, Walter, you've done a good job, but just remember, you may have actually cleaned it better than that image shows, because as soon as you screw the next piece in to seal it, that might have broken some more stuff loose on you. So, but it was worth doing.
Yeah, I'm happy with the final result, but when I filled it up with dust, you know, I was afraid I had ruined it. So I don't want to go through that again. So after I take all my my lights and darks and flats and biases, I stack them, and I've used all different programs for stacking. You know, Cyril. I've used Deep Sky Stacker, Auto Stacker. I've never used Photoshop, but I know it can be used for that. I'm not going to go through the stacking process. the instructions for each program are pretty straightforward. You know, you add your darks here and your flats there and your lights there and biases there, and then you hit the stack button, right? So I'm not going to go through that process. I have, however, experimented how doing or not doing these calibration frames helps or doesn't help. So this is fresh. This is from last week, and this is how the final image looks if I use calibration frames or not use them. So with no calibration frames, there's haze everywhere. There's that shadow from my off-axis guider, and then obviously those big dust bunnies that we saw earlier. If I use darks and biases but no flats, this is how it looks. And this is how it looks with flats but no darks or biases. And this is how it looks with everything. So for me, at least, it is worth to put the time into doing all the calibration frames. So, all right, I go through all that stuff, and then at the end, you know, the program stacks it, and it gives me a picture that looks like that. And Mark, how do I? There we go. Are you guys able to see my desktop?
Yeah.
Okay, so this is an actual image of the capture that I did last week. So there's not much there. When I first got into taking pictures, I had a really hard time figuring out how to get from this to this. So what I have learned since then is how to stretch the image, how to crop it, curves, do some basic color adjustments, how to use gradients to remove the background glow, and how to reduce noise and blend your foreground object into the background, so that it looks natural. Okay. And I wanted to put all those slides in the presentation and cover all that with you guys, but the more I did it, the least I was able to like explain it. I couldn't explain what I was talking about on the picture. So if it's all right, I don't know how we are on time. I instead of doing that would like to like spend 5 minutes actually doing the image process. So are you guys able to see my Photoshop screen?
No.
No.
We're still
Okay.
seeing the presentation.
All right, so let me see how.
You may need to exit.
Okay. Exit. How about now?
We're still not seeing your Photoshop. I think you might need to find it on your taskbar at the bottom and
Yeah,
click
you
on
probably
that.
should. You're sharing your browser. Share the screen instead. So stop sharing, then share screen.
Ah, okay.
There it is.
You
Voila.
can see now? Okay.
Yep.
So, you know, one of the things that I try to do before I do any stretching or anything is crop the image. And I don't know if you can tell from this image that there's some artifacts from the stacking. You know, my images were not perfectly aligned when I took them one night and then the other night, and then when I did the meridian flip. So there's artifacts around the edges and these edges. So I like to crop that out so that it doesn't affect my histogram. Regardless, there's a lot of dead space because the galaxies are fairly small. So I just like to crop it the least I can without including any of those stacking artifacts. So I highlight the area that I want to keep, and then and by the way, I use Photoshop, but all these methods I have used GIMP before because it was free, and all these methods are also available things you can do on GIMP or other editing software. But once I got my area highlighted, I crop it, and then all those artifacts are gone. And I like to duplicate my layers so that if I mess up, I can always just delete it and go back to where I started. So you know, the first thing I do is you know, stretch the image or stretch the histogram until, there we go. I couldn't figure out how to close the picture of you guys so I could see my screen. So I like to so stretch the histogram so that all the dim details inside the picture become visible. And I imagine that all of you guys that have done editing have done this. So I'm just gonna do it. I'm just gonna do it a couple times real quick so that we can bring out the galaxy in there. And I like to do it slowly, not to overdo it all at once. I'd rather just do it multiple times until I have a decent result, because I don't want to blow it up on the first try and then have to start over. So I just do it many times. And as you can see, the more you stretch, every time you stretch your histogram, it starts bringing out more and more details. And maybe do it one more time. And I try not to go past where the data starts, because I don't want to clip any data. After spending, you know, all kinds of hours trying to get it, I don't want to clip it and then lose it, because you know, I don't know what this little tip right there is, if it's the nebulosity of this arm or that over here. I just don't want to risk it, so I try to stretch it enough, but without clipping any of the data. And so once I have stretched it to where I'm satisfied that I've gotten the details out that I want, I also use curves to kind of darken the darks and lighten up the midtones, so that the details are kind of equal throughout the picture. You know, you can always play with this and just find the setting that's right for you, because at the end of the day, you know, there's no right way. You know, the picture is right when you like it, when you like the way it looks, because we're doing this for, I guess, for ourselves and for us to enjoy it. So, you know, I mess with the histogram, with the stretching, and with the curves until I get to a point where I think the picture looks good. And then after this, I don't really go overboard much. You know, I don't increase the saturation to 100% or vibrancy, all that. I do like to change it, but not too much. So for editing the colors on my pictures, I at least in Photoshop, I use just a raw camera filter, and that's too much. And I just play and change just a few settings. I don't change everything that's available. You know, like vibrance. I do like to add a little bit. You could use the slider. You know, whatever you think it looks good on any of these settings is the right amount to add. You know, I just like to keep my objects looking as natural as possible. So I just add or subtract a little bit of whatever setting. You know, I do want the colors to come out a little bit, so I'll add some saturation. I do want the details in the arms to come out, so I'm gonna add some texture and some clarity. And that's pretty much all I add. You know, obviously anybody will add or change the settings that you know, they like. So once I have changed the color settings that I like, I'm pretty much done with the editing of the image itself. This picture is actually pretty uniform in the way the sky looks. Sometimes I have pictures that come out really blown up on one side because either the moon's out or because the city of Chicago is over here, or there's a bright street light. So I'll have a very dark side and a very bright side. So I have a gradient that goes from dark to light, and I need to use some way of making it uniform. The way I do that is by adding a gradient, and the way I do that is I add an empty layer to my workflow here, and then I take color samples of the background sky from one extreme to the other extreme, and then I add the gradient to that empty layer, right? And I did it backwards, so it's like that. So I have this gradient now that represents the color of my sky background. Right now it's covering the whole picture, but if I choose a different way to blend it into the picture, it could, you know, benefit the picture rather than block it. So, you know, there's different ways to blend that gradient to your picture. You know, if you choose to subtract it from your picture, it'll make the background darker. I don't really know what these filters do, so I just like to go over them and see how they look. And once I find a filter that looks good, I choose that one. Or not a filter, I'm sorry. Once I choose a blending mode that looks good, that's the one I choose and I keep. I'm not necessarily looking for a filter that turns the background very dark like that. I'm more interested in looking for a filter that makes the background look smooth, because I can always make it darker using levels and curves, but I can't make it smoother. So if I find a blend mode that makes the background smooth, I keep that one, and then I just use levels or curves to darken it a little bit. And I don't like to make the background too dark, because then at least again, I was trying to edit the gradient instead of the actual picture. So, you know, once I'm happy with the way the background looks, I just darken it enough to where it looks natural to me. I don't like to make my pictures so dark that they look edited look like they're fake to me. So, you know, I like to remove enough background to where the center of attention is the image I took, but the background still looks three-dimensional. And that's pretty much it. Other than you know, if you look at where the galaxy ends and where the you know, deep sky begins, there's a lot of noise, some pixelation, and even the background itself has a lot of noise. There's several ways to make this look better, more natural. The way that I do it is by using a special selection tool called color range. And what I do is I select highlights. And what this does, it allows you to choose, you know, it allows you to choose, I guess, whatever the highlight of your picture is as the selection. And these two settings, you know, allow you to choose the sensitivity of that tool, along with adding some fuzziness, so that the selection kind of like feathers out into whatever's not selected, so that it can be blended more naturally. And I like to use as much of the allowed tolerances that I can without blowing up the picture. This is what I mean by that. Like, you know, I can't use 100% feathering, because then it's going to select everything. Then there would be no point in doing the careful selection to begin with. So anyway, so I select that and hit OK. And as you can see, it's selecting everything that includes my galaxy, as well as all the stars. What I want to do is to select the opposite of that. I want to select anything that is not a galaxy and it's not a star. So once this is selected, you just go to selection and invert your selection. And then I use in filters, I use reduce noise. And then reduce the noise. And with everything that we did, you will know that what is selected currently is our background, the deep space. So this is how it looks without adding this filter. A lot of pixelation, a lot of background noise. This is how it's going to look like after we add this filter. So that just smoothened out all the background. And now I'm going to go back to invert the selection again, so that now my galaxy and stars are selected again. And I'm going to go ahead and reduce noise on that itself, but not as much. You know, I don't want it to look like a smooth object. You know, I still want to see the detail in the arms and all that. So I'm on the galaxy itself, I'm only going to reduce noise maybe by 1 point or maybe 2. And be done with that. And then now if you zoom in, you can see how the background is nice and smooth. You still retained all the detail on your subject, and then the transition between subject and background is a lot smoother, a lot less noisy, and it looks a little bit more natural. And you know, once I get to this point, I'm pretty much done. You could always crop it some more to make it bigger, or change the aspect ratio so that it looks good on your computer as a wallpaper or on your phone. And at this point, you could also like continue to edit the colors until it looks you know, until it looks beautiful. But, you know, that's pretty much all I do. So, and that's an imaging session in Walter's world, guys. Thank you for joining me.
Thank you, Walter. Thank you. Excellent. Does anyone else have any questions about it?
That's fantastic. Thank you.